Hi, this is Boshi. Today I want to talk about the second question of homework 6. For the second question, there is three parts. For the first part, they want us to find B so that the above definition function is a valid joint PDF. And they already gave us fx is equal to b and x squared plus y squared is less and equal than 1. So from the x squared plus y squared is less than equal than 1, we can figure out the graph of this part, which is a circle, because as we know, x squared plus y squared is equal to 1, which means it is circle. And from this function, we already know the radius of this part is 1. So this is 1. And we want to use x to know what is the length of y. So which is square root 1 square minus x square, which is the length of y. And for the negative part, which is the square root of 1 square plus x square minus x square for the negative. So we can use this part to calculate out the b, because we already know the length of x and the length of y. So which is from 1 to negative 1 and square root 1 minus x square to negative 1 minus x square, and b times dx times dy. So we can calculate out, because as we know this part is equal to 1, so when we calculate out the b, take derivative of this part, so we can calculate out the b. So we can make b out first because it's just a number, and take derivative of 1, which is 2 times square root of 1 minus x square times dx. Sorry, this part is y because this is for the value of y and this is for the value of x. So we can, it's left times dx. Because it's 1 in here, so just take a derivative is this one minus this one. After that, we can take derivative of this part, because in this part is difficult to take derivative, so we need to make it become cosine square theta. And as we know, it is circle, so in this part it's just changed to pi over 2 to negative pi over 2. And this part is equal to 2 times cosine theta square of cosine theta times d theta. So for this formula, we can easily to change it to b times take derivative from pi over 2 to negative pi over 2. This part become 1 plus cosine 2 theta times d theta. And when we take derivative of this one, it directly equal to b times pi, because this one is equal to 1, so this one is equal to 1, so b is equal to 1 over pi. So this is the answer for the b. After that, they want us find ex and blah blah blah. There is many function. So let me calculate out one by one. Firstly, I want to find the ex first. For the ex, as we know formula, from theta to negative theta, from theta to from infinity to negative infinity, from infinity to negative infinity times x, because I just want to calculate x and fx y, x and y. So this is just formula, and we put the number into here, like the first one, and x times, because we already know the b, so we can directly use b, is 1 over pi times dy times dx. So we can, because dy first, so we can make x out in here, and this just number we can make it out also. So take the so we can get 1 over pi from 1 to negative 1 x times x, from 1 minus x squared to negative square root from for 1 minus x squared, 1 times dy and times dx. So take derivative, same as the first part, which is equal to x 2 times square root 1 minus x squared times dx. After that, we can take derivative of this part. We can get, which is 1 over negative 3 times 1 minus x squared for the 3 over 2, from 1 to negative 1, we can calculate out which is equal to 0. So Ex is equal to 0. After that, we can write out Ex smaller y is equal to 0 also, because Ex is 0. So for this condition, for this function, it's also become 0 because Ex is 0. After that, we can use a theorem to calculate out to calculate out Ex and y. Also, Ex and y. We can use a theorem which is E of y x, which is equal to Ey. This is just a formula from lecture. I want to use this formula to get Exy. So when we apply Exy into this formula, which is Ex equal Ex and y, I just apply this formula into here, and because this part is 0, as we know, so we can know E of 0 is for this. We can prove E of 0 in this part, and we can also get this part is 0 from this one. So Exy is 0. After that, for Ey, it uses the same idea like Ex, so we can write it out very fast. So same idea like the first one, we can calculate out Ey is 0 also. So same as the above part, Ey for the small x is 0 also because Ey is 0. And use same idea like the above, use the same theorem, we can prove Ey and the big X is 0 also. So for the last part with Ex times y, so in this part we need to use formula to calculate, which is 1 over pi from 1 to negative 1, and 1 minus x squared to 1 minus x squared for negative, and x times y times dy times dx. This is just formula we can calculate out. Take the derivative of part, I just ignore the process, so which is equal to 0 also. So this is the second part of second question. For the last part, which is prove or disprove x and y are uncorrelated. If we want to prove x and y are uncorrelated, we need to prove Exy is equal Ex times Ey. So from the above part, we already know EX and EY is 0. So EX times EY is 0 times 0, which is 0 also. And from this part, we already know EXY is 0. So we can know EX times EY is equal EX and Y, which is equal to 0. So from the theorem, which is X, Y are uncorrelated because EXY equal EX times EY. So this is for the second question.